Hello there, it's Jay here from Jay's Vintage Junk, and I'm going to try and do something a little bit different today. I'm just going to try and show you how to do something, or at least try and diagnose the fault anyway. What I've got here is I've recently dug an old Apple IIe computer out of the attic with hope of getting it up and running. I powered it up the other day and I'm getting a load of graphical corruption on the screen, so there's obviously something seriously wrong with it. I don't think it's probably RAM. I think it's probably either the ROM or the processor or something like that that's amiss. Anyway, I was doing some basic tests on it. I started pulling all the cards out of it and just see if the bare board would fire up, see if it was a card issue. I got all the cards out of it. I switched it on and I got this sickening, crackling, popping noise coming from the power supply, followed by a little bit of smoke whiffing out the back of it. I switched off nice and quick, and I'm pretty sure, I've not opened this up yet, I've pulled it out the Apple II. You can see I've got it on my bench here. I'm pretty sure I already know what's wrong with this. As I've shown in a few of my other videos, there's certain capacitors that are in all these old vintage power supplies, and most of them are getting on for 30 years old, or at least up there now, and they're failing, and I think that's probably what's happened in here. So we'll whip the top off, we'll have a quick look inside it, we'll see what damage has been done, we'll see if there's anything else it needs doing to it, and we'll have a quick look at seeing if we can repair it. Okay, let's get started then. I suppose I'd better get inside it first. It's these screws here and here to get inside this power supply, so let's start. I know it's probably quite boring watching screws come out. I don't know if I'll speed this up or not. I'm actually using a real camera. Well, nearly real camera. It's a cheapy thing I got second hand today. I've been previously using an old iPhone to record things, which works well enough and it's a high enough definition, but I have to hold it. This has got a camera mount on it, and I've got it screwed onto a tripod so you can actually see me work. I don't know what the quality is going to be like. It proposes that it does high def. I know it records a couple of hours footage on its internal memory, so yeah, I'm going to have a go with that. I bought two of them actually for I got them for £7.50 each from the local cash generator place. One is not working and the one is working, but it was in the clearance line. The not working one actually is a really expensive JVC one, I found out, and the only reason it wasn't working is it hadn't been charged properly. Anyway, we are inside the power supply. If this is for your first look inside a Apple power supply, as you notice I don't have it plugged in, because with the top off on these there is some nasty voltages around in here. You can touch certain things in here and that's end game, I'm afraid. So make sure it's unplugged. There's also a few capacitors in here that you really want to leave these things at least a few hours before you work on them, because these caps here, they charge up to 200-250 volts, and they will hold that charge for quite a bit of time. I wouldn't say it's fatal, but you put your finger on the back of one of them, you're definitely going to know about it. It hurts. Believe me on that one, because yeah, I've done it a few times in the past. So this has been off for a few days now anyway, so that shouldn't be an issue, and I will just show you how to discharge them if you so wanted to. Anyway, let's have a quick look. See, aha! I think we've found the culprit straight away. Yeah. Not if we can see this on the camera. Let me. Oh dear, that's first time I've hit the camera. Right, now there we go. I don't know how well this is coming up on here, but can you see that there? That cap has got in the smell. I wish this was smell-o-vision. Burnt toffee. These always smell of burnt toffee, but as you can see it's blown its side there. That's well and truly cracked open, and it is one of the Weimer or Riffer. I think they might even be made by the same mate. They both make this type of capacitor. It's one of them and it's gone. I notice there's also another one there, 0.47 UF, same type. It doesn't actually look that cracked, that one, but I'm probably going to change that as well. We'll get that out and we'll replace that, and we'll take that out. We might take that out. We'll have a look at it once we've got that out and we've got the board out of the case, and we'll possibly replace that one as well. While we're in there, I think we'll do a bit of checking on some of these other capacitors. But let's see if we can get that board out. Oop! Yeah, that's not good. Remind me when I do this in the future, don't keep knocking the tripod. Right, now lovely. It's held in with these little nuts. Now we've got, let's see, we've got one there, we've got one there, we've got one up here, we've got one over there, and I think it'd probably be easier we take that earth off there as well. Right, and oh, they're all sealed with varnish as well. Lovely. So makes them twice as hard to get off, but at least it means they don't work loose. Right, now these probably best with a nut spinner to get these off, but everything's up in the air here at the moment, and I don't know where it is. So, and my good one's up at my other workshop, and I couldn't be bothered going up there for it tonight. So let's get these off. Let's see if we can get that off. There we go. I must say, quite nicely built, nicely laid out. Obviously passive cooling on these power supplies. There's no fan in here. I think they did say that they were quite unreliable at the time, but it looks well made. It certainly does look well made. Come on out there, I don't want to damage that earth wire. I know that varnish is beneficial, but it's a pain in the arse, I'll tell you that. It binds up the screws. I suppose you could put something on there to dissolve it before you tried taking the nuts off, but oh, I don't know. Let's have a look here. It's nearly out, I think. I wonder if I can speed all this up on the video when I try and edit it. I've actually got some proper editing software now as well. A friend of mine at the company I used to work for, I asked him, he's a photographer, he's a cameraman, an editor, video editor, and I asked him about what software would be good, and he said he'd have a word with their studio manager and see if there was anything they were getting rid of. And I saw him the other day, and he brought me home a boxed brand new copy of Final Cut Pro for the Apple Mac. You know, I've got an old dual core Mac in the other room, which I think it should run on quite nicely, so I'm going to have a go at installing that. And seeing these little camcorders a solid state, I can just whip the card out, stick it in the Mac, and hopefully edit up these videos quite easily. Because I enjoy doing this, but unfortunately I don't have a huge amount of time. I'd rather spend my time repairing things than sitting editing on a computer. So that's why up to now I've not really bothered with this. I've only just literally grabbed hold of my phone and held it there and done a bit of a piece to camera, so people could see what I'm up to. Because I might end up with something a little bit more professional off this. I doubt it. I mean, I'm not budding to be an expert at this. I can't see me in the league of like EV blog and all that lot. Absolutely love his stuff, but he spends a lot of time that I just don't have. He also is a lot cleverer than me as well. I don't think I could ever do electrical engineering as a full profession. I do a bit of it in what I do now, but it's all on the repair side, not on actually designing stuff. Right, so that's them out. Let's see what we need to do to get this power supply out of the case. I think we do well if we can can get that out there. Let's have a look, see what we can do that with. Let's try this. Ooh, that's not going to be easy, is it? Yeah, that's going to be a tricky one, but we could really do with getting that out of there. Let me have a look in my tool drawer. Another stupid thing I've managed to do is put the tripod of the camera in front of my tool drawer, which means it's an absolute bugger to get anything out. Hey ho. Let's have a go with these. Is that working? There we are, that's out. That's got it. So we're free there. Now let's have a look here. Now I think we're probably better if we unhook this switch. So let's see what I can get that out with. No, that's just ridiculous. Let's have a look in this drawer. Possibly. Let's have a go. There we are, that works actually. Just needs a bit of leverage because I don't want to pull on the wires. Come on, out you come. There we go. Now, remember that's top. Get out. There we are. There we are. And that's bottom. Not that it really matters. And yeah, the one to the far end over there is top. So come on, out you come. Out you come. We've certainly tight these. Only like there. There we go. And we've got one more at the bottom there. We can just pop that out. I'll have to get hold of it with these. Let's have a look here now. There we go, that's out. So, top, bottom, they're out. I think I'll have to get that earth off as well. I was hoping to leave it on. I might be able to. It's going to be a bugger to get off. Let's see how this works. Look at that, that's lifted now. Now, I think I have to pop the switch out. See if this will do it. There we are, that's popped out there. Winkle out the switch. Yeah, that's coming out. Come out, you little bugger. Come on. Come out, you little bugger. There we are, there's the switch out. Keep that out there. Now we'll lift this again. Again there. Right, and then come on. There we are. That's out. Oh, come on. One side in, one side out, one side in, one side out. There we are, we're out. We're free. Let's have a look underneath. Ooh, yeah, you can even see that now. Right, okay. Now, these are what we are interested in. Now, this first capacitor is here. Let's see if, just bring that back further into shot. I don't know whether any of this is in shot, you know. Right, this capacitor is here. Okay. Yeah, that's okay. Right, so we need to get that out. Let's get some soldering stuff out. I tidied this bench up the other day and it's already full of stuff again. Let's move, I'll put that in my drawer. Right, soldering stuff. Or desoldering stuff. We have a solder pump. Let's have a look in here. Oh, some new stuff. Oh yeah. We have some solder braid. I've just bought some new of this, and it's the thicker one. I don't really like the thinner one, I don't think it ever works very well. So we have some solder braid, we have a bit of solder, snap a bit off. There we are, lovely nice bit of solder there. Okay, I do have some liquid solder as well. Coffee. I do have some liquid solder flux as well, but I don't think I'll need it for this. So we have the iron. Let's just clean the iron's bit off a little bit. Yeah. There we are. That's better. Tin that up. There we are. Okay, and we're ready to go. So, idea is heat the pin up. I like to apply a little bit of new solder because these are old. Take your solder sucker and poof. If it doesn't get it straight away, just go back in and poof. There we go. That doesn't look too bad. And let's try the next one. Let's heat that pin up. Bloody fluorescent lights. There we go, heat that up. Now get it nice and hot. Come in with a solder socket and poof. Perhaps a little bit more on that one there. Just heat it up there again and pop. Okie dokie. Let's take off the other one while we're there, because I want to give it a proper inspection. We can always replace it, put it back on the board if there's nothing wrong with it. So, oops, oh that's not good. Don't have gaps in your desk. There we go. So let's put a bit of solder on that like that. Heat it up. Solder sucker and pop. It's quite a big one, so I think it's going to need a couple of attempts. Come on, heat it up and pop. Yeah, I think that's got it. And we're on to this one. So let's heat it up. There we go. Do you watch that? You see the other side just pop out? There. Oh, look at that! Dropped straight out the board. Now let's clean that off. Let's put the soldering iron away. Let's take the joint up. Yeah, look at that. That one's dropped straight off the board. Oh, the Rifathi around there, so I think I will replace that just as a matter of course. And let's have a look at the other one. Give it a whittle. Give it a whittle. It's free. Ah, there we go. There we are. Ugh. And there we are. Look at that. Not very nice. Not very nice at all. Right. So, first things first, we need to replace them. And we have 0.47. That's an X. So it's an X-rated capacitor. It's an X2. Which means it's suitable for going right across the mains. And this one is 0.1 UF, and that's also an X2, so it's suitable for going right across the mains. So let's see what we can replace them with. Now let's just have a look in here. Ooh, yeah. Let's see what we've got. Now that 0.47, right, so that will be replaced by that. It's a different style package, but it's X2 and it's the correct value. So we've got that one. Now let's see what we want for the other one. Well, that's a Y class. These, let's have a look at these. No, they're the wrong value as well. Let's have a look at what we've got down here. I've got a lot of 0.22s and I want a 0.1. This may have to go, yeah, another one, 0.22. Alright, let's put them for the bin pile. I think I've got another load of X2 caps. Let me have a look in my other drawers. Here we are. Look at that. Right, what have we got here? That's another 0.22. Yeah, I've got a hell of a lot of 0.22. Well, I'm sure we've got something. Let's have a look at one of these. What are these? There we go, 0.1. They're a similar type of package to that. So there are our new capacitors. Put them away for another day. Yeah, it's a slight. I don't think I've got anything else in there, have I? No. Right, they'll do. One's not ideal, but it'll do the job. It's electrically, it's correct. It's just a slightly different size package, but I'll show you how to get around that anyway. Right. Now, so those are quite nice. What I'd like to do, because these are the new old stock components. I tend to buy up bulk components when they're places have gone bankrupt, people are retiring, that sort of thing. So sometimes they've been in storage for some time. So just a really quick, you can do this with emery paper, sandpaper, anything really. Just give the legs, if they're looking a little bit tarnished and a little bit dull, just give the legs a bit of a scrape up, like that. You can see them going a bit shinier. It just helps the solder to adhere to them, so you're not relying on the flux to cut through the oxidation. Same with this one. That one's not near as bad, but just give it a really quick scrape over, like that. Just like that. Doesn't need any more. There we go. Right, let's look at fitting these to the board. Now, yeah, right, okay, well that's good anyway. The board's been designed for different sizes and different styles of these components. So, that one will slide in there like that. Yeah, that's a nice, that's quite a nice fit. I'm happy with that. Now this one, this is a bit bigger than what would have originally been fitted. So what we'll have to do is we just take some snips, bend the leg like that, do the same on this side, oops, without dropping it. So we just bend it over, bend it back, there we go, just like that. Now that should fit. So if we stick that back in the board, oops, oopsie. No, I think it's here in that hole and that hole there. There we are. There we are. And that's the new component fitted back in there. Yeah, I'm happy with that. Let's just make sure they're nicely seated. Just bend them legs out a little bit just to keep that flush onto the board, and we can solder them into place. So a bit of solder on there, let it flow onto the board, that's nice. Bit of solder on, oops, a little bit of solder on there, let it flow onto the board, just like that. Do this one as well. Okay, and the last one. Okay, that's good. Right, so that's them in place. Now where are my snips gone? There they are. So then all we need to do, now you see people like this, press on there and let the leg ping off. I've had one in the eye, so safety first. Just hold on to the leg, especially if it's a big hefty brute like that. Plus these are useful sometimes, so I do like to keep a few in a little pot for just bridging things. Down we go, clip it off, down we go, clip it off, there we go, and as we can see, there's the new capacitors in place. Now what I am going to just quickly do while I've got it open like this is these caps, I'm not going to test them all now. I'll be testing the voltages on this thing after anyway. I was just replacing them two capacitors because obviously you're not going to run something with components in that kind of state. So what I'm just really quickly going to do is I'm going to grab my ESR meter, which is this thing here. This is a cheap Chinese ESR meter. I'm sure you can get much better ones, but it was dirt cheap and it does the job. So let's get that on there. Let's check which way is positive and which way is negative on these capacitors. Okay, right. So what we've got is there and there. Those two are the negatives. And then the next one is backed round, so there's the negative, and then it backs around again and there's the negative. So let's switch the old ESR meter on. Short the probes so it can compensate itself. Right, now it's ready to go now. Now I'm just going to hold the probes on. You could change these crocodile clips for proper probes, but for doing this should be fine. So let's try this first capacitor. This one's quite nice, this ESR meter, because it will mostly work in circuit. So let's have a look here, and that is coming up as 0.52 ohms. So 0.52 ohms, and it's a 47 UF capacitor at 250 volts. So if we look here, 250, we go over to 47, it's good capacitors in ohms is 2.50, and we were getting, where's my there we are, we were getting less than an ohm. So that capacitor looks like it's pretty good. Let's try the next one. All these ones I'm testing are all the same. They're all 47 UF at 250 volts. So let's have a look at the next one. So it's the same ground rail, and then it's that connection there. And again, it's perfectly fine. Now the next ones, we need to spin these round. Go there, and there. And again, 60 ohms, it's absolutely fine, that. And the last one, on there and there, 1.19 ohms. Again, it's fine, that, really. I wouldn't say that's a problem. It's a little higher than the others, but it's good. It's good. I'm happy with that. So I think them caps have probably fight to live another day. Yeah, they're 1000 UF at 16. Let's just try one of them just to be on the safe side, shall we? Let's try that one there, because that's an easy one to get to. 1000 UF at 16. This side here is negative. So let's get a good contact on that. Get a good contact on that. 0.02 ohms, that's very low. Right, okay, let's have a look on the chart here. It's 16 volt, it's 1000 UF, 0.11, and what was we getting? .02. So yeah, that's absolutely fine. Right, I'm going to put it back together now then. Let's just kill the meter so it saves the battery. Right, now let's look at putting this thing back together. Okay. Now, there we go. That slides in there, and that's gone in there. Put these last two lugs back on. Yeah. As I say, I could have done a lot more thorough checking on this thing, but what I will do is I'll reassemble it, and then I'll do a test on it. Just offload. I'll make sure nothing's dragging too high, and then I'll stick it back in the Apple. I'll measure the voltages in the Apple, and that should give us a good indication whether it's all happy or not, without risking the Apple, because obviously if we test it while it's offload and the voltages are ridiculous, we'll investigate. Well, we'll try putting a dummy load on it. This is really bad. I really need to find what's happened to my nut spinners. This is not professional. It's not good practice to do this. It really isn't. Right, okay. Oh, fuck. Right. Last one to go back in. Oh dear. Struggling with that one a little bit because it's quite close to the power connect, so let's get it with these. There we are, that's it. That's it. Let's just give it a last. There we go. Right, let's get this back in. That should just push back in, hopefully. I think we'll have to get it with the pliers. Let's have a go with the pliers. Squeeze it slightly, give it. There we are, that's back in there. That's strain and release fine. Right, now switch. Put the switch back in. That should just snap back in like that. Now, as we said, wire to the inner, goes to the bottom. There we go. Wire to the top, outer to the top, and the same for the other side. So this one, oops, rather warm tonight. That goes down there like that. So push that firmly onto its connector. There we go. Push that on there like that. That's good. Straighten up the new component. There we are. And make sure he's nice and straight as well. There we go. So that's pretty much it. Get the screws ready. Right, so put the cover back on. Unless you know what you're doing, don't run it with the top off. That's a really bad idea. Like I said, there's things in here that when the mains is on can be live, and you touch the wrong thing and it's game over. So now it's back to that. Let's put the lid back on it, if I can find what the hell I've done with it. Come on, what have you done, lid? What have I done with the lid? What have I done with the lid? There it is. Ah, there we go. And there we are. So as it goes in the Apple like that, that goes on like that so it can be read. Let's put the screws back in. Okay, tighten them down. That's good. The power supply is going to need an exterior clean. It's got something sticky on the top of it. I think some drink's probably gone into the machine at some point in its life. Feels a bit like Vimto. It's like purple tint to it, so it's some kind of cordial Vimto or something like that's been spilt on it in years gone by. Not by me, I must hasten. But that's what happens with all these old computers. Like I said, once upon a time they were nothing but just junk. Some people think they're just junk now, but I'm not one of them. No, definitely not. I love this old stuff. I'd much rather be repairing this than a modern amplifier or something. There we go, make sure that switch is in there. And that's the power supply rebuilt. Like I said, I've not done a full restoration on that, or else I'd have changed all them electrolytics. But we've tested a few and they're looking fairly good, so yeah. That's good. I'll see if I can find an IEC lead, and in fact, is that plugged in at the moment? No, that's not plugged in. We will find an IEC lead and we will power it up and check some voltages on it, I think. Now the question is, where do I have an IEC lead kicking around here? I'm sure I have. Ooh. Nope. Okay, that's better, we've got one. Oops. And we have an IEC lead. Now let's plug that in up there, like that. I don't know if anyone can see my meter. I'll put it at a jaunty angle so I think everyone can see it. Yeah. Let's move some of these tools out of the way, let's not have a cluttered bench. And go back in the drawer. There we are, let's move that out of the way as well. Have a nice uncluttered bench. Right, let's plug that in. I've got a little bit of coffee left, yeah? Okay, let's plug this in. There we are, that's IC power in. I've not switched it on there, and I've not switched it on at the wall yet. Let's just have a really quick look here. Yeah, you can't see my digital test meter, so let's just move that up there like that. Okay, now I've just moved that up there like that so you can see my meter there. Now that's set to voltage. We're on 10 volts at the moment. It's quite good, this meter, because it goes like plus and minus like 20%, so 10 volts is fine for testing a 12 volt supply. The overrange is really good on it. I really like that meter. I paid about a £5 for it from a radio rally years and years ago. Okay, I think that'll do for testing. Right, now I haven't actually looked what the pin out on this is, but we can be pretty sure that black's ground, and we'll see what's on the other wires. So we put a probe in ground like that. Ooh, these are really tight. Okay, let's try something else. Now, where are them bits of wire that I saved? There's one. Now what we need, yeah, let's have a look here. There we go, that'll do. We can unplug that probe there. We'll plug this one in. A crop clip on the end of it. I think we'll let's get some pliers here. We'll fashion ourselves a bit of a probe. We bend that over and pinch it down really tight. Yeah, that's a bit smaller than the multimeter probe. That should do it. Now we can put that down. There we are, that's better. That makes good contact. We clip on, because we're pretty sure black should be negative. There we are, like that. It's not going to do any harm if it's not, to be honest. And we can then, that's not needed now, we can then probe the other pins and find out what we get off it. So, let's power up there, let's power up there. Well, no bangs, no magic smoke released. Let's see what we've got. Let's probe there. Alright, we've got a voltage there, but it's only small. Let's have a go there. Again, there's a voltage there, but it's nothing fancy. Let's try here. Nothing. And nothing. Right. Now let's try in there then. Could just be we weren't getting a good connection. Perhaps there's more wrong to this power supply than meets the eye. Yes, nothing there. Plus point something of a volt. Oh, we're definitely testing voltage, aren't we? And we're definitely on DC range there. And we're testing at 10 volts. This is interesting. Let's try in there. No. There. No. That is interesting. So, we may have something wrong with this power supply. Oh, hang on. Or am I a complete doofus? I am a complete doofus because I didn't have the bloody power supply switched on. There we go, that's better. 5.2 volts off load. That doesn't look too bad. 11. I'd like that to be a tiny bit higher, but I wouldn't say it's horrendous. So we'll look here. Minus 4.8, yeah. Then I would like that to be a little bit higher, as in close to minus 5 volts than minus 4, but it's not horrendous. Minus 11.2, yeah, again, I'd like it to be a bit closer to minus 12, but it's not terrible. Right, so the power supply actually, after I've gone out of idiot mode, yeah, that's not too bad. I mean, a minus That's plus 11.86. And we've got minus 11.22. It's, like I said, I'd prefer them to be closer, but they're in the ballpark anyway. So I think I'm happy with that power supply now, enough to put it back into the Apple and to use it for further testing. And I think that's as far as I'm going to go for tonight, because I'm getting tired now and I need some rest, and yeah, I think that's enough for tonight. So I hope you enjoyed that. I hope you enjoyed me watching me do a simple repair on that power supply. Yeah, I will carry on with the restoration of the computer. It might be in a little bit. Yeah, I'm really busy at the moment, but as soon as I get time I will have this back in the Apple, and we'll carry on with the diagnostics. Okay, thank you for watching, and goodbye.